In May 2009, a wildlife warden stood at the edge of a loch in Knapdale Forest, Argyll, and opened a wooden crate holding 11 Norwegian beavers. Britain had been without them for 400 years. Within months, the water level had risen. The shoreline had changed shape. 11 animals had rebuilt what centuries of costly human rewilding schemes never managed to touch. What they constructed was unreal. The Scottish Wildlife Trust and the Royal Zoological Society of Scotland had spent years fighting for this moment. Permits, public consultations, government reviews, all of it to return one animal to one forest in Argyll. It was the first legal reintroduction of an extinct mammal in British history. No species had been brought back this way before, not here, not officially. The 11 animals came from Norway, a population that had recovered quietly while Britain stayed empty. They carried no instructions. They had no map of Knapdale. They simply moved into the silence and began. 11 animals. A single family group entering a landscape that had forgotten their weight, their smell, their teeth on green wood. 4 centuries without a single felled stem, a single dammed channel, a single flooded hollow. The forest had grown in their absence, but it had grown wrong. Drainage fast, water thin, shorelines rigid and bare. Decades of wetland management schemes had come and gone across Britain. Engineers with diggers, planners with blueprints, budgets approved and spent and approved again. The water table barely moved. Then these 11 animals chose a loch. They did not consult the management plan. Within one season, the water level had risen. The shoreline had changed shape. The woodland edge was flooded and alive. A beaver dam is not a wall, it is a slow argument with gravity. Sticks packed with mud, water backing up behind, the whole forest floor rewiring itself outward from that one crossing point. What the trial team documented inside that first season was a hydrological shift no engineer had achieved at this site. New wetland. New standing water, new habitat, emerging without machinery, without a salary, without a single planning approval. And yet, the 5-year trial was designed to measure whether these animals could survive, not whether they could outperform every wetland programme in modern British history. The trial was asking the wrong question entirely. Stand at the edge of any Knapdale loch on a grey October morning and the place looks complete. Old oak, dark, peat-stained water, the soft percussion of rain on still surface. The lochs sat at a fixed level, year on year. The shoreline vegetation had settled into a narrow, static band. The same species, the same width, occupying the same few inches above the waterline. No flooding pulse had moved through here in centuries. No mud exposed and recolonized. No dead wood half submerged and rotting into the water column, feeding the invertebrates that feed everything above them. That is the part that surface calm conceals. Stillness here was not health. It was the absence of a force that once kept this system unstable in all the right ways. In the River Tay catchment to the north, a population had re-established without official sanction, and the contrast with nearby managed drainage channels was already measurable. Fluctuating water lines, drowned tree margins, exposed mud recolonized within a single season. Knapdale had no such comparison. It had only the flat quiet of water that had never been interrupted. Across Britain, every freshwater system that once moved with this kind of engineering had slowly forgotten the shape of a fluctuating water line. 4 centuries is long enough for a forest to lose the memory of being interrupted. In Argyll's broader upland forests, the cycle these animals drive, impounded water, drowned trees, opened canopy, new light reaching the surface, had simply stopped. The forest edge had grown uniform and closed where it should have been ragged and wet and alive. And here is the contradiction that the field teams could not easily explain. The forest looked intact. The surveys confirmed it was missing something invisible. Not a tree, not a bird, not a plant. A process. Remove a process for long enough, and the landscape reorganizes around its absence. The species that needed fluctuation thinned out quietly, one generation at a time, until nobody was left who remembered the flood. That is what 16 animals were released into. Not a broken landscape, but a quietly diminished one. A system running on what remained after the engineer left. The question no one had yet answered was whether 16 animals could restart a process that 4 centuries of managed land had methodically, quietly, completely erased. For generations before the release, the conservation teams working Argyll's wetlands arrived with diggers. They cut channels by hand, adjusted sluice gates, managed reed beds with schedules drawn up months in advance on paper. A sluice gate holds the water where the engineer last set it. It cannot read a dry July, salmon running upstream in October, and understand that the pond behind the dam needs deepening right now this week before the gravel silts over. That gap between a managed level and a responsive level is not a small engineering detail. It is the margin where invertebrates colonize newly exposed mud, where amphibians breed in the shallows that appear and vanish with the season, where willow roots find purchase in soil that has just been turned wet. No engineered impoundment has ever produced that margin at scale. The machinery was always doing something, but never the right thing at the right moment, driven by the right hunger. The opposition to the Knapdale trial was documented and serious. Livestock farmers worried about flooded grazing land. Fisheries managers worried about dams blocking migratory runs. Foresters counted trees that would be felled and ring-barked inside a 5-year window. Those objections were formal enough to require a 5-year licensing trial before permanent status could even be placed on the table. 5 years to build a case? 5 years for the land to answer back? Within that trial, the dams the colony built raised the water table in their immediate catchment and held it elevated through a dry summer that strained every managed impoundment nearby. The sluice gates were manually adjusted twice that season. The beaver dams adjusted continuously every night, without instruction. The programme's biologists recorded invertebrate diversity returning to sections of the loch margin that had been ecologically static for as long as the monitoring records reached back. Not recovering, returning. Something that had been gone was recognisably coming home. Then came a result that stopped the field team cold. The fisheries objection, the one built on the assumption that beaver dams would obstruct migratory salmonids, did not materialise the way anyone predicted. The colony modified dam structure in ways that allowed passage. Nobody had designed that outcome. A management plan answers the question its author thought to ask. What no plan had ever managed to answer was the question the wetland itself was asking. Season by season, depth by depth, in a language that only one species in Britain had ever been fluent in. In 2016, the trial ended and the beavers were granted native species status, permanent residents, not probationers. What that decision set in motion beyond Knapdale is a different scale of story entirely. Beyond Knapdale, the legal ground had shifted, and with it, every watershed in Scotland became a place where the argument was no longer about permission. It was about pace. The Beavers had chosen a loch and pushed its shoreline outward into the surrounding woodland, not cleared it, not drained it, pushed water into it, slowly, incrementally, the way a tide reads a shore. Where that water reached the root systems, the trees began to die upright, standing, still rooted, but no longer living. And a standing dead tree above open water is not a loss. It is one of the most productive micro-habitats a temperate forest can generate. Woodpeckers opened the bark from above, drilling cavities the wood could not have offered while living. Invertebrates colonized the submerged grain from below, finding wet wood that had not existed here in living memory. Waterfowl found nest sites in those same cavities within seasons of the trees going silent. The gnawing along the water's edge opened the canopy. Light reached the loch surface at angles it had not reached for decades. Aquatic vegetation responded first. You could measure the change by what returned to the shallows. Then the insects that depended on that vegetation. Then the fish, moving into submerged wood and deepened pools, finding structure where there had been none. Each step followed the previous one the way water follows a slope. Nothing was planted, nothing seeded, nothing directed. The physical conditions had been rebuilt from the waterline inward, and biology simply filled the gradient. What the field teams documented at Knapdale was not a managed recovery. It was an instability restored. The dam did not create habitat. It recreated the fluctuation that habitat requires, and fluctuation is exactly what 4 centuries of drainage had removed. The populations spreading beyond Knapdale into the River Tay catchment have now built structures across dozens of riparian corridors. And the carbon held in the new wetland soils those structures generate has not yet been fully measured. The surveys record the extent. The accounting is still running. That is not a footnote. Peatland and wetland soils are among the densest carbon stores a temperate landscape can hold, and a beaver pond accelerates their formation by flooding ground that drainage had kept dry and oxidizing for generations. 11 animals arrived in a forest that had forgotten them. What comes next is the question no one had thought to ask before the first dam went in. What happens when the rest of Scotland's rivers get the same answer? The licensing document had a perimeter. The Beavers did not. They followed drainage gradients the way they always have, not toward a boundary line on a map, but toward the next viable channel, the next blocked flow, the next ditch that offered a drop in elevation worth engineering. The monitoring teams had designed the trial around containment, a defined area, a defined population, measurable outcomes within a fence that existed only on paper. What they documented instead was a pattern that no licensing framework had anticipated. The effects of the engineering kept moving outward, season after season, past every notional edge of the designated zone. In the Tay catchment, a separate population had already been building without any official sanction at all, no release permit, no monitoring protocol. Those animals had arrived on their own terms, and their dams were appearing in drainage ditches that farmers had maintained for generations. The Knapdale trial had begun with 16 animals across its designated release points. The Tay population answered to no such number. It had grown beyond any count the original design had imagined, and it was doing so in a landscape of active agriculture. A blocked agricultural ditch is not an abstract ecological event. It is a flooded field in a wet country, in a season when a farmer cannot afford to lose it. The tension was not theoretical, it was documented, it was recurring, and it had no legal resolution at the time it was happening. A beaver's engineering logic and a farmer's drainage investment pull in opposite directions. The beaver raises the level. That is the mechanism that builds the wetland, slows the flood pulse downstream, and silts the carbon into the soil. The farmer lowers it. That is the mechanism that keeps the field viable, the crop dry, the season recoverable. Neither is wrong. They are simply incompatible without management. This is the part that made me stop and reread the field notes. The permanent status decision in 2016 did not simply declare the beaver a native species and close the file. It built a management framework around the friction, acknowledging, in formal policy language, that the same animal delivering ecological restoration on one bank could be blocking a drainage investment on the other. That framework included provisions for intervention, where engineering caused genuine agricultural loss. It gave land managers a mechanism they had lacked entirely during the unsanctioned Tay expansion. The trial had produced not just ecological data, it had forced a country to write rules for a species it did not know how to live alongside anymore. An animal re-engineers drainage at the catchment scale. It does not stop at a fence, and the question the Tay population had already answered, before any official model had even asked it, was how far the effects travel when nothing constrains the range. Scotland had spent 5 years measuring what 16 animals did inside a designated site. The Tay had been running a different experiment entirely, Feats. One nobody designed, with no perimeter and no endpoint. And the catchments beyond both of them are still waiting for the same question to arrive on their banks. The loch at Knapdale does not look managed anymore. The shoreline has gone ragged in the way that healthy shorelines go ragged. Root tangles in the water, sedge pushing out into the shallows, willows leaning where the bank has been undercut by a slow, deliberate rise. That is not disorder. That is a shoreline doing what shorelines evolved to do across hundreds of millions of years. Accumulating structure, slowing water, building ground. It just had not been allowed to do it here for a very long time. The field teams that monitored the site through the trial years documented something that does not appear in engineering models. The raised water table had begun recruiting plant species that had no recorded presence at the site within living memory, arriving through seed dispersal, through wet soil that finally held moisture long enough to let germination occur. Wetland plants store carbon at roughly 5 times the rate of upland grassland. That is not a minor footnote to a wildlife story. That is the same ground doing 2 jobs at once, the way it always did before the ditches came. What the loch had retained underneath 4 centuries of absence was its capacity. The hydrology was still there, compressed, interrupted, waiting. The moment the water level climbed again, the system responded as if no time had passed at all. That is not metaphor. That is seed banks, soil chemistry and gradient doing exactly what they were structured to do. I have watched this pattern repeat in river valleys across this continent and across Europe. You remove the pressure, you return the piece that was missing, and the system does not hesitate. It moves because it has always known the direction. The part that stays with me, the part the recovery data keeps circling back to, is that 400 million years of wetland biology does not require our instruction. It requires our restraint. Drop your region in the comments, and one species you personally watched disappear, a bird that used to be everywhere, a fish that ran the river, an insect you stopped seeing so gradually you almost didn't notice. And yes or no in the comments, have you ever seen something come back that you were certain was gone for good? Because if the answer is yes, I want to hear that story. Share this with someone who still believes the damage is permanent because the evidence says otherwise. Grey wolves were returned to Yellowstone in 1995, and within a single generation they changed the course of rivers. The Park Service had spent decades trying to stabilise with concrete and labour. The US Fish and Wildlife Service opposed the reintroduction until 1994, citing livestock predation risk, and the elk response that followed made every prior grazing management model obsolete. The question those rivers left open was whether the new channels the wolves carved through shifting prey behaviour would hold, or slowly drift back toward the old courses once the predator pressure stabilised. The land does not wait for permission. It moves the moment the missing piece returns.